Hi, in this video I'm going to go over an approach to implementing the card game War in Java. This is just one approach, and this way of doing it is a way that I like. It may not be a way that's compatible for you, but what I want to emphasize here is the importance of planning out your solution before you start to code. Right? You want to have a clear solution, no matter how you do it, no matter what approach you use. You want to have a clear solution before you sit down and write code, if possible. Right? Sometimes it's not possible to do this. You have to sort of go through a series of steps where you write some code that gives you ideas, and then you go back to your plan. And we may need to do this here, right? We iterate through a series of solutions that get progressively closer to a excellent solution. So anyway, and to be honest, I've coded up War in the past. I haven't done it yet for this project. I deliberately did not do it because I didn't want to sort of force you in a particular direction. I want you to each, or in your pairs, I want you to come up with solutions on your own. So, but let's go through this quickly. So you notice that I'm basing this on the existing deck and card classes. Programming these days is very much a modular enterprise. We're building with modules that exist and work. You don't start from scratch. It's like if you're building a house these days, you don't build your own windows. You buy windows from a window manufacturer. You don't build your own doors. You buy doors. You don't build your own cabinets. You buy cabinets from a manufacturer, etc. Right? So in programming, we want to try to use existing modules when we have them available, and then we put them together in new, interesting ways. So some things we need to implement the War game. So we need two players. We need to represent two players, each with a hand of cards and a pile of 1 cards. So I've indicated that with this blue box here. That's going to be a class, a player class. And and then we need a table, so to speak, where the action occurs. This needs 2 stacks of cards that after each turn are moved to the winning player's pile of 1 cards. So that's what that rectangle represents, right? That's the table class. Okay. So now let's come down here. So now I've expanded the player class, and as you can see, the player class has contains 2 deck classes. Now neither of these will be full decks of cards, but the deck class has most of the functionality we need for maintaining the player's hand and their stack of 1 card. So I have the H here to represent their hand. This is a deck object that represents their hand of cards, and this is a deck object that represents their winnings. Okay, and there are 2 of these player objects. So between them, they're going to create 4 deck objects. Right? The deck objects will be filled maybe in the constructor for the war game from a from a deck from a shuffled deck. And so that will be one additional, right? I haven't represented the class for the entire game here, but that class will also have a deck object. So that's 5 deck objects at this point. Might as well draw one here in, what color am I using for this? So we're going to need a deck object we'll call it the war class or the game class, okay? Itself, and that will be initialized to contain a full deck of cards and then shuffled. And then from that, let's go back to yellow, right? The cards will be dealt out, one to this player and one to this player, to their hands, right? Until all the cards are distributed to their hands. Then what happens is, the way I learned war is you do 3 cards. Each player puts down 3 cards. These would come from the player's hand, right? So 1, and these are put down face down, 3, right? And each player does this from their hands, 3 cards, and then 1 face up. And since this is all being automated, right, it doesn't, we could, in the printout, we might show this 4th card. Now, if, say, this player's showing card has a higher point value than this player's showing card, then all the cards in both of these deck objects shuffle off to the winner's pile of winnings, which is a deck object, right? So they just get added to that deck object. Alternatively, if this player wins the war, then they all get shuffled off to his or hers. But we do have the case where if the cards are the same here, right, at the same point value, then we repeat the process of the 3 cards and the 3 face down cards and then the face up card, right? They just get added to each player's stack out here on the table. And again, if the turned up card, both stacks of cards go to the winner, if there's a winner, of the second time the turned up cards are, whichever one's the higher one. So, and that goes on as long as you get matching cards here. Another 3 down, another face up, right? So during that process, a couple of things could happen. Number one, a player could run out of cards in their hand. This could actually happen at any time. In which case, what you want to do is move all the cards from the deck, from the winnings deck object over to the hands deck object, right? And that sort of repopulates the hand, and this is the programming equivalent of taking your winnings pile and straightening it out and picking it up and putting down your cards from it, right? Now, in playing the real game, you might take your winnings and stick them on the underside of your deck, your hand, and that I wouldn't recommend that here because there's some issues related to the cost of shuffling things in the array list to do that, right? You'd have to shuffle because those cards that are coming from the winning section go on the bottom of the deck of your hand. It would require shuffling up all the existing cards in your hand, which could get quite expensive in terms of time, right? So that's one of the things that could happen, right? Your hand could empty, and then you'd have to move over all of the cards in the deck over to your hand. The other thing that could happen is that you run out of cards in your hand, but you don't have any cards in your winnings pile, in which case you lose the game. So you have to look for both of those situations, right? So you need to have some way to know that a player is out of cards and therefore loses the game. Okay. So let's just review. You're going to create, or if under this scenario, I would create, you may approach it differently. You're going to create a player class, and then you'll have 2 player objects, and you're going to create a table class, and you'll have 1 table object. Each of the player objects will contain 2 deck objects, and the table will contain 2 deck objects. And of course, each of those deck objects will contain a certain number of cards. You'll also, in the class, the war game class, you'll have a object of the deck type that's fully populated with a deck of cards, and in the constructor, perhaps those cards are shuffled and passed out to the decks that represent their hands of the 2 objects. Okay, so I could take this another step and start doing pseudocode, but at this point, I think this is enough for you to give you some ideas about how you would start planning out a solution to this project, right? You want to start at a very high abstract level and work the processes out as carefully and as logically as you can. And then once you're pretty sure that you've got a solution that makes sense, then start coding. Okay? Thanks.